you learners, wherever you are. I salute you once again from your various homes, hoping that you're fine in these hard times. I'm here again to share with you the normal lessons that we normally have. I'm proud to present to you another very unique topic in mathematics, which is called scale drawing. So I believe this topic, at the end of the lesson, you are going to be able to calculate any question which is related to scale drawing. So this question is common. It must be there whether you like it or not. So scale drawing comes in different setups. So I'm going to do 3 questions or 4 questions of different setup, and you'll be able to know how to approach such questions. So I'm here now to make some approaches to our first question, that is on scale drawing. So one thing I want to put across is that a scale drawing is normally a representation of a place or a specific location, or a road. It can be a road on a map. When you look at the paper I'm holding now, this paper, the much it can go, the length it can cover, it can be not even more than 30 centimeters. Or even if I use a manila paper, it cannot be able to accommodate a length or a width of a house. Meaning, a real length cannot be represented on a piece of paper like this. So what we do is that this one, the measurements are reduced into the drawing lengths. So in this case, you'll hear me talking about the real length, So in this case, another name for real length is the actual length, So a real length, it's the real measurement outside this piece of paper. For example, maybe a road can be of 1 kilometer long. So you cannot draw a kilometer on a piece of paper. So 1 kilometer is the real length. So because it can't be presented on a piece of paper, we now reduce it into the drawing length. So we have another type of measurement. We call it the drawing length. So a drawing length, it's a type of length that is used to represent the real length outside this particular piece of paper. So in this case, we prefer using what we call a scale, and that's why we call it scale drawing. So I'm gonna now move to our first question, whereby we shall be calculating the real length or the drawing length, or sometimes you can calculate the scale. So in this case, when you want to represent a place on a piece of paper, you have to use a lower or smaller units. So in this case, I know learners, you are aware of millimeters, centimeters, meters, and kilometers. So millimeters and centimeters are quite smaller lengths, which can be drawn on a piece of paper. But a meter and a kilometer can be quite big and cannot be drawn on a piece of paper like this. So in this case, the scale on a paper is 1:50,000. So you can see on this scale, we don't have the units. The units are not written here. It is just written 1:50,000. So in this case, I'll write my scale is 1:50,000 or 1:50,000. So why are the units not written here? Because this is a scale. And I started by mentioning this, that when you're representing, when a scale has been given out to you, just assume that it is centimeters. The units which have been used here are centimeters. So in this case, 1 centimeter represents 50,000 centimeters. So you can now expound on this. So you just write 1 centimeter represents 50,000 centimeters. So these are the units which are used to represent an information on a piece of paper. So after you have expounded on this, you can now go on and read the next statement. The question asks, find the actual distance. So the question is the actual distance, meaning a real length outside this piece of paper. Find the actual distance in meters. So one thing you have to be aware of, you must be given the units which you're supposed to convert your real length into. So this real length, which is meters, is the one which will help us to know how we convert our scale. So in this case, we shall convert our scale into meters. So in this case, you remember the formula which I passed to you on the other time. Kenya has dug many dams containing magic. If you maybe don't remember some of these conversion units, you can revisit the video and learn them. So in this case, we shall change 50 centimeters into meters. So our unit stands that 1,000 meters, 100 centimeters is equals to 1 meter. So why am I writing this conversion here? It's because my relationship is between centimeters and meters. So you can see I want to change this scale into meters. So, and the relationship between meters and centimeters is that 100 centimeters will make 1 meter. So what about 50,000 centimeters? So I'll convert these. What about 50,000 centimeters? So I'll cross multiply. So this is going to be 50,000 centimeters times 1 meter over 100 centimeters. So I convert centimeters and centimeters. I'll simplify centimeters and centimeters, then zeros and zeros. So I have 500 times 1 meter, which is 500 meters. So I have converted my scale into meters. So what I'll come and write is that 1 centimeter represents 500 meters. So what does this mean? Every 1 centimeter I draw on this piece of paper represents 500 meters of a real length. So that's what this scale explains to us. So the question is, find the actual distance in meters, which I've already converted the scale, represented by 7.2 centimeters. So sometimes it's very simple. If I draw 1 centimeter on this piece of paper, I have represented 500 meters of a distance outside. So if I draw 2 centimeters, if I drop 2 centimeters here, I represent 1,000 meters. If I draw 3 centimeters here, I will represent 1,500 meters, and so on and so on and so on. So the question is, what about if I draw 7.2 centimeters on a piece of paper? So because I can keep on redoing this one time and again till I reach 7.5, but what I want you to write is this. Just go back to our first statement and write. If I draw 1 centimeter, it represents 500 meters. What about if I draw 7.2 centimeters? What does it represent? That's the question. So now you cross multiply. So in this case, it's going to be 7.2 centimeters. Then you multiply by 500 meters. Then I'll divide by 1 centimeter. This cross multiplying. So you simplify the centimeters and centimeters. So what I'm left is multiplying 7.2 by 500 meters. I'll just assume the decimal. So you can just multiply 72 times 5. This is 0, then 36. Then add the 2 zeros. Then replace back the 1 decimal point, which is here. So it is 3,600.0. And the number 0.0 is the same as that number. So in this case, the answer is going to be 3,600 meters. The units must be the one that is left without being simplified. So the answer is going to be this. So when I draw 7.5 centimeters on a piece of paper, it will represent 3,600 meters as the real length outside this piece of paper. So, and that is a simple explanation on how one can calculate a problem associated with scale drawing. So you're going to work out the next question and see how these questions keep on coming and how they change. Now, let's go to question number 2 and see what the question demands us to do. So this question states, a rectangular field, and I've said earlier that when you read a question that is talking about shapes. Please draw the shape. So a rectangular field. So I'm going to draw a rectangular field here. This is a rectangle measuring 600 meters by 400 meters. So this is 600 meters by 400 meters. Is to be represented on a map. So you can see this is a field. This field is 600 meters and you cannot draw 600 meters on a piece of paper. With then we have 400 meters, you can't draw this on a piece of paper. So it's upon you to find the drawing length so that you can be able to draw this one on a piece of paper using the scale. So the scale that was used was 1:20,000. So write that scale here. 1:20,000. In this case, every 1 centimeter that you draw will represent 20,000 centimeters. And I said you must use the same units. These are just the same units which have been used here as when it comes to defining a scale. So 1 centimeter will represent 20,000 centimeters. What I've done here is interpreting the scale. This one and this one is the same. Only that this one has been written in a ratio form. What will be the area? The area of the map. This map here. And this is a rectangular field. So you know, this question now has to take you some miles and find the area of the same field. So, and the units which they require you to find the area in should be in centimeters square. So now we begin our work. So you can see, using our scale here, because the question is what will be the area of the map in centimeters square, you can use the scale to convert these units here. The real length is 600 meters and the real width is 400 meters. So it's asked to convert this real length into drawing length, real width into the drawing width using the scale. So what I'm going to do is I'll change this one here, 20,000 centimeters into meters, because the relationship here I'm talking about is centimeters and meters. And what is our relationship? 100 centimeters will make 1 meter. So after knowing the relationship, it's very simple. So what you need to do here is you have to divide by 100 centimeters. So this is by 100 centimeters. So this one, you can simplify that and that, and then you have 1 centimeter represents 200 meters. So every 1 centimeter I draw, I represent 200 meters. So I have already converted my scale. So I can use my scale to convert the length and the width. So I'll draw my field here, and I will insert the drawing length of the field. So I'll convert each. 1 centimeter represents 200 meters, so I'll convert the length. What about 600 meters? I'll put it down here. 600 meters. Remember, they must be under where it's where the units rhyme. So you cannot put it under here because this is centimeters and you cannot put a meter below a centimeter. So then you cross multiply. So this is gonna be 600 meters times 1 centimeter over 200 meters. So indicate the units. You simplify meters and meters, 0 and 0, by 2 1, by 2 3. So we have 3 times 1 centimeter to have 3 centimeter. So in this case, 3 centimeter will be the real length here. So in this case, when I draw 3 centimeters, I represent 600 meters on the, I represent the real length of 600 meters. So I go to the width using the same scale. 1 centimeter represents 200 meters. So I'm converting 400 meters. What about 400 meters? Cross multiply. So 1 centimeter, that one will be 400 meters. Then you multiply by 1 centimeter. Then you divide by 200 meters. So you begin your work. Simplify that and that. 0 and 0. By 2 1, by 2 2. So 2 times 1 centimeter is going to be 2 centimeters. So the drawing length is 2 centimeters. So what does this mean? This field is 600 meters. But when I draw it on a piece of paper, I'll use 3 centimeters. This width is 400 meters. But when I draw it on a piece of paper, I'll use 2 centimeters as the drawing length. So let's visit our question. What will be the area of the map? And the map is a rectangle. So the area. So what is, because it's a rectangle, area of a rectangle is length times width. So area is going to be, what is the length? 3 centimeters times, what is the width? 2 centimeters. So area is going to be 6 centimeters square. And this is what the question was demanding. Your map in centimeters square. And here we have arrived. So I read my question. A rectangular field measuring 600 meters by 400 meters is to be represented on a map. I have represented. Using the scale, I've used the scale. What will be the area? I've done the area. In square centimeters, this is my answer. So it's good to read and confirm your working and whether you are correct or wrong. Now learners, let's go to question number 3, which is I'm trying to look for different questions in different formats, but they all fall under scale drawing. So in this question, it demands something different other than what we've been calculating in the former questions. So here, the question says, H walks a distance of 4 kilometers. H walks a distance of 4 kilometers from his home to town. To show this distance, he drew 0.2 centimeters. What scale did he use? So the question now demands you to find the scale. What scale did he use in ratio form? So in this case, this man, or this boy called H, he walks a distance of 4 kilometers. And when you tell that particular boy to draw that 4 kilometers on a paper, he cannot be able to do it. Because a kilometer is so big to be represented on a piece of paper. But now he decided that he will use 0.2 centimeters to represent 4 kilometers. Remember, you don't just sit down and guess the units that can represent a certain real length. No, you have to come up with a unique scale. That is a unit scale of conversion. So in this case, we want to know which scale did he use. So what you're going to do is, I'm going to represent this here. That this boy, let me write this one here. So this is the real length. The real length is 4 kilometers. And here, the drawing length is 0.2 centimeters. So it means when he draws 0.2 centimeters on a piece of paper, when he draws that, he represents 4 kilometers. So that's what I'm going to represent here, just as the English is communicating that when I draw 0.2 centimeters on my paper, I will represent 4 kilometers. So math is all about English, understanding. If I draw 0.2 centimeters, I represent 4 kilometers. So in this case, you can see the units now are different. If you remember when I started this, I said a scale must be represented using smaller units. This can either be in millimeters or centimeters, but in most cases now we use the centimeters. So I'll convert the one which is not in centimeters, and in this case is kilometers. So I'll convert 4 kilometers into centimeters. Let's go to our relationship. How many centimeters will make 1 kilometer? If you go back to your formula, you'll realize that 100,000 centimeters will make 1 kilometer. What about 4 kilometers? So I'm converting 4 kilometers, then I cross multiply. So this is 4 kilometers, and I always advise learners to write the units. Times 100,000 centimeters over 1 kilometer. Then you can simplify the kilometers and the kilometers. You realize that your answer will be in centimeters, the units which has been left and cancelled. So 4 times 100,000 will be 400,000 centimeters. So what I've done here, I've just converted. So this one is what, instead of now 4 kilometers, I'll write this. because I've converted into centimeters. So I'm going to write 0.2 centimeters is equals to 400,000 centimeters. So you can see now the units are the same. So what are we left with? Simplifying. We reduce this number until the ratio must start with 1:2. But now you can see it is starting with 0.2 represents 400,000 centimeters. So it's upon us to reduce this. But when you look at this one is a decimal. So you have to remove the decimal. Because if I count here, there is one decimal number here. So what you need to do is you can multiply both sides by 10 to remove the decimal, the other side by 10, like that. What you do on this side must be done on the other side. By a 10, by a 10. Why am I doing that? To remove the decimal. So it's going to move like that. Then I remain with 2 centimeters is equals to 4 million centimeters, like that. So now I can simplify because now it's not a decimal. So the number that can simplify on both sides I see is 2. So just look for the common divisor. But according to me it's 2. So you can divide by 2, divide by 2. So this is by 2, 1, by 2, 1. So I'm now left with 1 centimeter is equals to, by 2, 1, by 2 here is 2, and all the zeros, 1, 2, 3, 4, 5, 6. So I write here 2 million centimeters. So I'm now okay because now I have 1 centimeter representing 2 million centimeters. So what I'll do here, I'll now simplify the centimeters and the centimeters because I told you in a ratio form you don't write the units because you've been told to write your answer in ratio form. So now you represent that 1 is to 2 million, like that. 1 is to 2 million. So this is your answer. So what COH use, the scale that COH uses 1 is to 2 million to convert the real length, to represent the real length on a piece, on this particular piece of paper. So, and that's how easily you can reach up to our answer. So you can see it's simple working out these things if you only observe and make the same approaches which I have just made. Finally, let's go to the last question, still under scale drawing. And the last question, I told you that this question will be in different formats. So when we work out together an example like this, look for as many examples of the similar type and work them out. So the question says, the following is a plan of a playing ground. This is a plan of a playing ground. Drawing to scale, drawn to scale, it should be drawn to scale. The following is a plan of the playing ground drawn to scale. 1 centimeter represents 20 meters. So write that scale. 1 centimeter represents 20 meters. What is the actual perimeter in meters? So the actual is the real. You can see these units, centimeters. What you can see is 5 centimeters, 4 centimeters, 8 centimeters. This one clearly tells you that this one is not a real length. This is the drawing length that was used to draw some real length, which we are yet to know what are these lengths. So the scale that was used here was 1 centimeter represents 20 meters. So the question is, what is the actual perimeter? So if when we interpret this question together, perimeter is the distance around a given figure. That is, if this is a field, I think we have done this before, you have to go around this particular field up to where you started from. That is perimeter, so you can add round. But before we arrive up to that point, there are some things that we need to do here. We need to know what is a real length that was represented by 5 centimeters. Similar to 4, similar to 8. But now we have to convert using the scale. So the question is in meters. What is the actual perimeter in meters? So let's go to our question. Do we have meters somewhere? 1 centimeter represents 20 meters. So this one is okay. We don't need to convert this because I already know that every 1 centimeter represents 20 meters. So now we start converting this measurement here. So let's begin. 5, if 1 centimeter represents 20 meters, what about 5 centimeters? Cross multiply. So it's gonna be 5 centimeters times 20 meters over 1 centimeters. Like that, like that. So 5 times 20, you'll have 100 meters. So what I always recommend is that you can write that one in bracket, 100 meters in bracket. So what does this mean? The 5 centimeters that was drawn on a piece of paper is equal to the length of 100 meters, which is a real length. So you go to the same thing we do here, the same thing we do with 8, and so on. So I'm going to go to the same thing. So 1 centimeter represents 20 meters. What about 4 centimeters? So I cross multiply. So when you cross multiply this one, you'll get that this is 80 meters. And the same thing when you do with this one here, you realize that it will be 160 meters. So just do the same conversion. You realize that the answers will be that way. Now we have converted. We are good to go on. What is the actual perimeter of this? So perimeter is distance around a given figure. Look at that, 100 meters. Now we don't use this, we use the actual length. So this is it, 100 meters, but I don't have this. I have 160 meters, I have 80 meters. So I don't have this one here. So if you recall this one is hypotenuse. This one is a triangle here. So the question was testing you whether you can remember how to calculate how to use the Pythagoras theorem. That is the hypotenuse, to calculate the hypotenuse. So in this case, the length, the height of this triangle here is the same as this. So I can write there 4 centimeters. So I can use the actual drawing length to find the hypotenuse. Then I want to know what is the base of this triangle. So from here to here is 5 centimeters. From here to here is 8 centimeters. So therefore, if I want to know the units here, this one I'll take 8 minus 5, which will be 3 centimeters. So this measurement here is 3 centimeters and this is 4 centimeters. So I can use the base and the height to find the hypotenuse. If I just remind you, when you square the base plus square the height, the answer you get, find the square root, it's gonna be the hypotenuse of that triangle. I repeat, when you square the base added to the square of 4. So let me demonstrate here. So when you square the base plus you square the height, the answer is gonna be hypotenuse square. That is when you find the square root of the answer that you get. So this is now 9 plus 16 is gonna be the square root of the answer, which is 25. So you can see. So 9 plus 16 is 25. So the square root of 25 is 5. So this 5 here is the hypotenuse. So you can remember this because this one is the chapter that you covered earlier. So now I have all the measurements. So what I need to do now is on my final chapter, the perimeter. Distance around a given figure. But now in this case, you can see 5 centimeter is a drawing length. So we have to convert to the actual length, which you still use the scale. You convert this the same way you converted, and you realize that it's gonna be 100 meters. So you just convert the same way we are converting here. So now the perimeter will be this. Let's now run around this field. This 100 meters. I write 100 meters. This 100 meters. I go this way. This is 160 meters. Remember, I'm using the actual length. Go back to where we started from. That is 80 meters. So perimeter now is going to be 100 plus 100 is 200 plus 160 is 360. 360 plus 80 is going to be 480. So this is 360 plus 80 is going to be 440 meters. So the question was saying, let's go back to our question, what is the actual perimeter in meters? So the answer is that my actual perimeter is 440 meters. If the question was, maybe could have changed to this format, what is the actual perimeter in what is the drawing perimeter? The drawing perimeter will be 5 plus 5 plus 8 plus 4. That is the drawing perimeter. But now the actual, because the question demands us to find the actual perimeter, that is what we have come up with. So otherwise, with these very few examples, but very crucial ones, I believe that now you are good to go on calculating any problem which is related to scale drawing. This question, I told you, it can never miss in any exam. And it can come in any of the 4 formats which I have displayed here. So in case of any question and inquiries, just contact us. We have a big team here. Our YouTube channel is Peter Namasaka. So this video, as it's been uploaded there's a number which will appear on the screen. Just contact us and we'll be able to reach on to you. Or if you have a guardian at home or your teacher nearby you, let that teacher give you as many examples of this. And I believe as you move forward, you're going to be a successful learner, and if you're a candidate, you're going to shine at the end of it. So otherwise, have a nice time. God bless you.